Okay, so today we're going to spend a little bit of time talking about system word problems, application and analysis, and this kind of leads a little further into what we've been talking about with the word problems. So we're going to develop the equations and look at them graphically, and then kind of determine and compare and contrast different situations to determine which one is the best. Okay, so let's take a look at our first problem here. So Adam and his family are planning to rent a mid-sized car for a one-day trip. In the standard rental plan, they can rent a car for $52 per day plus 23 cents per mile. In the deluxe rental plan, they can rent a car for $80 per day with unlimited mileage. Okay, so what do you think the equations are? Do you think these are standard form or do you think they're y equals? Well, I don't really see two things in a total. So that means it's probably a y equals. It's probably a y equals mx plus b. So if I take a look at my first scenario with the standard rental plan, it says they can rent a car for $52 a day plus 23 cents per mile. Well, I know they both say per, but I'm only going to rent this for one day. So I think the 52, that's my constant. That's not going to change. So my first equation is y equals 23 cents. That should probably be a decimal because we are talking about money. So 23x per mile there, that is my slope, plus 52. So that's my first equation. My second equation, y equals. So it says they can rent a car for $80 per day with unlimited mileage. So my slope, since it's per mile, but I don't have to pay that, that would really be 0. And this $80, that wouldn't change. So I really have 0x plus 80 or y equals 80. Okay, so if Adam's family plans to drive 150 miles, which plan should they choose? So I went ahead and I graphed this for us. So let me make it a little bigger so we can take a look at it. And we'll use this to kind of analyze and decide what we want to do. Okay, there we go. So we're going to drive 150 miles. So 150 miles is over here. So I am looking at this line right here. So the green line, that's the $80 a day. And the blue line is the standard rental plan. So we have standard and we have the deluxe. Okay, so at 150 miles, who's cheaper? Well, the green line is going to be 80. The blue line is going to be maybe 85. So technically, the deluxe would be cheaper because it's a flat rate of $80. And the other one would be more than that because I've passed the number of miles where they're equivalent. So the break-even point is that it says 121.74. Let's round that off, and 80. Well, what is that? Let's see. What are my units? What are my units? Well, this is miles, and this is money. So at 121.7 miles, so almost 122 miles, it's going to cost me $80 on both of them. So if I'm going to drive 100 and just under between 121 and 122 miles, it wouldn't make any difference which plan I pick because it's exactly the same price. So right here, these are the same price. But if I'm going to drive more than 121.7 miles, then the deluxe would be the better deal. Well, what if I'm only going to drive 50 miles? Who's the better deal? Looks like the blue line is lower. So the blue line would be about $65 and this would be $80. So this would be the better deal. Okay, so it does have to do with how many miles I'm going to travel. So if I wanted to write like a statement that would kind of explain this, I could say something like, if I'm going to drive greater than 121.7 miles, then I would want to use the deluxe plan, which would be $80. If I'm going to drive less than 121.7 miles, I would choose The standard plan, because it would be less than $80. And if I'm going to drive 121.7 miles exactly, I can choose either one because it doesn't matter. They're exactly the same cost at that point. Okay, let's look at this next one. So we're going to ride an express bus from the center of town to our street. You have two payment options. Option A is to buy a monthly pass and pay $2 per ride. Option B is to pay $4.50 a ride. So the monthly pass costs $50. Okay, so option A would be, it's $2 a ride plus a monthly pass, and it says the monthly pass is $50. So that's got to be my constant. So 2x plus 50, that would be option A. Option B, it's going to be $4.50 a ride, but it doesn't have a monthly cost, so I don't have a B. So 4.50x would be that equation, okay? All right, so let's take a look at what we got here on our graph and make some decisions on when we should pick which deal. All right, so the orange is option B, and the blue is option A. Okay, so what is the point of intersection? The point of intersection is at 20 and 90. 20, 90. Okay, what are my units? What am I talking about? Well, my X value, how am I paying? I'm paying per ride. So my X has to be number of rides. So in this situation, the 20 would have to be the ride. So at 20 rides, and this is going to be money. So it's going to cost me $90. So both plans cost the same if I ride 20 times. They cost $90. Okay, it doesn't matter. All right, now it says, when should I buy option B? Well, option B is the orange. Well, it looks like the orange is going to be cheaper here. So I'm actually going this direction from that 20. So I think that would be if I'm going to ride less than 20 times. So that's less than. Okay, if I'm going to ride less than 20 times, I should pick option B. So then if I'm going to go the other route and I'm going the other direction and I want the blue, when is the blue better? Well, you're right. That's going to be greater than 20 times. And that is greater than. Okay, so as you're working today on some analysis things, you're going to be doing some compare and contrast and determining what's the best deal when, and trying to analyze what does the point of equilibrium mean. Remember, systems are pretty powerful when it comes to being able to comparing information. All right, our next step will be solving systems of linear inequalities. We're going to be looking for some double shaded regions, and we'll catch you next time.